In this lesson, we'll be looking at discrete probability distributions. So this example is for your notebook, and there's a little bit of notation that you need to understand first of all. So on the right hand side, the probability of a discrete random variable getting a certain result is written as, and use this correct notation. So you've got a capital P in brackets, a capital X is equal to X. And that small x is just the outcome of whatever the event capital X is. So if you imagine you're spinning this spinner, and that spinner could land on the number 1, 2, 3 or 4. So we have an event where the spinner is spun, and then we have an outcome with whatever it lands on. So the question here is, what is the probability of the spinner landing on the number 1? Well, there are 3 number 1s, so the probability is 3/8. Now we can show this distribution in a table as well, so that because there is a discrete number of possibilities, as in there are only 4 different outcomes there, either the numbers 1, 2, 3 or 4, we can write this in the table in this form. So we put all of the different outcomes, little x, across the top of this table. So we have 1, 2, 3 and 4. And then underneath we write the probability of getting that event to occur. So we've already worked out the probability of 1 being 3/8. So 2, we have 2 lots of 2 in that on that spinner, so that's 2/8. Number 3, we have 2 of those as well. And the final one, we have 1/8. And what you should notice is all of these probabilities add up to 1. So if there is ever one probability missing from a table, then you should be able to work out what that missing value is. There are a number of different ways that we could write the same information. So we have the distribution table at the bottom, and we could use this to write what we call a probability function. And it's written in a slightly different way, but we use the probabilities within this function. So hopefully you'll see that in a second. So the different probabilities are 3/8, 2/8 and 1/8, and then we always have an extra option at the end, which is what would it be if it wasn't one of these 3 things. So it would be 0. How do we get these probabilities? How do we get the probability of 3/8? Well, we get that when we have these values of little x. So 3/8 happens, it occurs when x is equal to 1. 2/8 occur when x is equal to 2 or 3. And 1/8 occurs when x is equal to 4. When does 0 occur? Any other situation, although it's impossible in this case because we only have 1, 2 and 3 and 4, but we always have to have this other or otherwise situation. So that the way that that function is being written at the top, that's called a probability function, and at the bottom we have that distribution table, and you can be asked to swap between one and another as well. Here are 4 questions for you to have a go at. The top 2, you are given the probability distribution and you need to complete the probability function. And then the bottom 2, you're given the function and you need to complete the probability distribution table. There are some values of k that you need to work out along the way. Pause the PowerPoint, have a go at this question, and then I'll demonstrate each of these in turn. So for the one on the left, we have a k under the number 1 that we need to work the value out. So if we add up the other 3 probabilities, so 1/6 plus 1/6 plus 2/5, that will give us 11/15. And k must be 1 minus that probability so that they would all add up to 1, and that gives us 4/5. So k here is equal to 4/5. From this point we can then draw our probability function. And so we start with the capital P, capital X is equal to little x, and then we draw this big open bracket, and we have our different probabilities. So we have a probability of, sorry, I've put 4/5, 4/15 there. 4/15, we have 1/6, and we have 2/5, or we have 0. When is the probability 4/15? When x is equal to 1. When is it a sixth? When x is equal to 3 or 4. 2/5 when x is equal to 6, and it is 0 otherwise. With a second example, we have two values of k here and here. Now 0.1 plus 0.4 is equal to 0.5, and 1 minus 0.5 is 0.5, so two lots of k must be equal to 0.5, meaning k is equal to a quarter, 0.25. So we now know what these two are both equal to. And so our probability function, set up in the same way, nice open bracket, our probabilities, and you'll notice that these, it doesn't really matter whether they are in numerical order, particularly as long as you have them all written down. So we have 0.1, 0.25 and 0.4, and then 0 otherwise, and we have 0.1 when x is equal to -2, 0.25 when x is equal to -1 or 0, 0.4 when x is equal to 1, and 0 otherwise. So for this question, we're going to start with the table. So we've got x and the probability that x occurs. So the outcomes here are 5, 6, 7 and 8. And here it says whether x is 5, 6, 7 or 8, k is the same probability for all of these. Now there are only 4 different outcomes, so 4 outcomes, and they have the same probability. And if all the probabilities add up to 1, that means that each of these probabilities must be the same 1/4. And then for the final question, set up that table again. If we take a look this time, we have 4 outcomes, 1, 2, 3 and 4, and we can't work out 4 until we've worked out the other 3 probabilities. So we're given this situation where we need to substitute something in for that probability. So when x is equal to 1, we have 1 over 3x, which means 1 over 3 times 1, which is a third. If x was equal to 2, then we'd have 1 over 3 times 2, which is a sixth. And x equal to 3, same idea, 3 times 3, so that's 1 over 9. And if we add those 3 probabilities together, so 1/3 plus 1/6 plus 1 over 9, that is 11 over 18, and 1 minus 11 over 18 gives us the value of k, so that is 7 over 18. Please complete the exercises listed on this slide. Over the next couple of slides there will be some hints and tips on trying to complete the exercises associated with this PowerPoint. Looking at question 1 on exercise 1.1, this is on page 182. The question is asking you to identify the discrete random variable x and all of the possible values of little x. Now what this is asking you to do, if you think about what we've looked at with these previous examples where you've had the probability of big X being equal to little x are the outcomes, and the big X, the discrete random variable, is what is the event, what is occurring, and what will you then be recording. So when you're looking at this question, tossing a fair coin 4 times and recording the number of tails, the discrete random variable part will be this bit here, recording the number of tails. And if you're looking for what are all of the possible values of x, then you have to work that out within the question. So if you're tossing a coin 4 times, what could happen? You could get either 0, 1, 2, 3 or 4 tails. So the little x would be between 0 and 4. For question 2, it says draw a table showing the probability distribution. Well, you're just drawing something very similar to what I've done here at the top. So just copy out a table, make sure that you put your little x, which are given within the question, at the top, and then all of your probabilities will go underneath, but you may need to work some things out. As you can see in each question, there is, also on most of these questions, there's a little x like here on top, so you'll need to work out some missing values for these. In question 3, very similar to question 2, it's just a little bit less information is given, so you still need to write out a table for all of the answers in here, but you will need to work out what are the x values, what are the values that go on top here. So you need to read whatever the event is. So here where you have, for part A, you have a capital A is equal to the score rolled on a dice plus 1. So you would have the probability that capital A is equal to x. What are those possibilities? Well, on a dice you have 1 to 6, but if you then add 1 to each of those, what would those little values of x be? And it's very similar for the others in that question. For question 4, it's asking for the probability function. So this time you will have probability of x being equal to little x with that open bracket. So maybe go back to the example questions and take another look at this if you do need a little bit more support with that question. Question 5 is another probability distribution, and so you've got the table again for this one. Now the difference for exercise 1.2, which is on page 183, you're going to get a few more sort of questions about the probabilities using cumulative probabilities as well. So if you're looking at the first question, I'm not going to have a look at part A there because I think that one's relatively straightforward to do. But if you're looking for the answer to, let's say, part B, find the probability that x is greater or equal to 2. That means you need to add together the probability of x being equal to 2 plus 3 plus 4. Or alternatively, remember that because all of the probabilities will add up to 1, then you could just subtract the probability that x is equal to 1, and that would give you the same thing. Be careful if you have a question that has either a strict inequality or not strict. So for part B, you want the probability that x is less than 2. That means you don't want 2, the probability of 2, to be part of that question, so you're actually only looking for the probability that x is equal to 1. And the other questions are in a similar kind of thread really, so some of them it's a little bit of working things out. So for question 2, find the value of k, so some of these have little k's in and you have to work those out, and remember that all of the probabilities add up to 1, so that is your starting point, making sure that they do. It's part 2 here says write the probability distribution, remember that's your table form. And then answer some question about the probabilities. And the others do work in a very similar way, so work out the table, find a probability, taking care with the strictness of the sign as well. And they do get a little bit trickier towards the end, especially if it's a little bit of problem solving, but nothing beyond what you should be able to do. In exercise 1.3 on page 184, the questions are getting a little bit more involved again here, so there's a little bit more working out before you start looking at answering some of the questions. So I'll give you an idea with question 1. It says you have an unbiased 4-sided dice with the scores 1, 2, 3 and 4, and the dice is rolled twice. The event x, the discrete probability distribution, is it's the product of 2 scores on the dice. So a good idea here would be to draw yourself a sample space diagram, 1, 2, 3 and 4, 1, 2, 3 and 4. So you have the first dice and the second dice, and you're going to multiply them because you want the product. So if you work out the answer to each of these, 1 times 1, 1 times 2, etc., fill in all of that table. Then what would be a good idea at this stage is to say, well, what are the outcomes of this event occurring? And so you'd be looking inside of this table to write down the possible answers here. So let's take a look. I'll just fill in a couple more and it'll give you an idea. 4, 6, 8. So the x values, the values that the event can take would be 1. That's this one. It'd be 2, 3, 4. Now there's no way of getting a 5 in there, so the next one then is 6, and you could continue up in this way. Then you need to work out this here. So what is the probability being between 3 and 10? Not equal to 3, but it can be equal to 10. So you then need to have a look at what the probabilities would be for this event to occur. So you'd be looking at the situation, the probabilities of these happening. And then the other questions in this do follow on the same kind of thread really. So you need to consider what the event is. Maybe write down a sample space diagram if that's going to help you. Certainly a probability distribution table like this one here would definitely help, and then have a go at answering the questions from there. For exercise 1.4, which is on page 185, these questions, they've given you the distribution function in its table form, but you need to complete a cumulative distribution function. So let's take question 1, part A. So you've got all of your outcomes x, and then instead of p of x, we want f. That's what's written in the question for this, the cumulative function. And then from here, you need to add up the probabilities. So you're looking at this one being the probability that x is less than or equal to 1. The second one is the probability that x is less than or equal to 2. So we need to add together 0.1 and 0.2. The third one will be less than or equal to less than or equal to 3. So that is 0.1, 0.2 and 0.3. So I'm adding together all of the probabilities as I go along, and what should happen at the end, if you've done it right, you should get to the total being 1 within each of those tables. Then obviously there's some other questions that then can be asked about those functions from there.